Well, like Dave already mentioned, so we want to show you now how we are going to bridge over from academia into industry and into the research area. And one very exciting example that we have seen from Airbus coming is what they call Factory of the Future. So, Asa, can you tell us a little bit more about Factory of the Future?
Sure. Factory of the Future is basically Airbus's plan to reinvent aircraft manufacturing. Now, this video gives you a really good idea of what their vision actually is. You see, aircraft manufacturing has some of the most challenging manufacturing requirements. They have to assemble heavy equipment, build complex electronic components, and then actually align all these things mechanically to be able to get the highest quality aircraft. And remember, we trust Airbus to fly us around the globe every year without falling out of the sky. So their quality is critical. Now, given all of this, the Factory of the Future is their research project to be able to evaluate emerging technologies, to be able to build their aircraft faster, more flexibly, and with higher quality.
Wow, so definitely inspiring this video. So how are they going to make sure that they bring this vision to life?
Well, Airbus believes very strongly that cyber-physical systems and data analytics is going to be critical to make their vision a reality. They also think that a platform-based approach will let them leverage their investment across the many areas that they're going to need to invest in to bring this to fruition. Now, their big plan is to be able to use the same code on a low-cost, say, production tool as they do on, say, a high-performance robotics control device.
So sounds quite challenging to me. So how does their approach to that look like?
Well, they started by trying to do it all in isolation. One team would build a smart production tool. Another team may build that advanced robotics controller. But what they quickly discovered was when they tried to have these systems communicate, or even more, share the code between the different systems, it was just too time-intensive for their small design teams. So then they tried a platform-based approach. They focused on building a single software framework that they could apply across the many different devices that they needed to build. Then their developers were able to focus on core algorithms like vision analysis or motion planning and really kind of free up their abilities.
Okay, looks like you brought us some sample there as well.
Yes. So this is an intelligent wearable device. It's similar to Google Glass. Go ahead and give it a shot.
Well, let's see if it makes me a little bit smarter.
Very nice. Very, very nice. So imagine you're a worker working on the new Airbus A330 airframe. Okay, around you are literally hundreds of thousands of different holes. You have to drill them, measure them, fasten them, and inspect them. That's where this technology really starts to make a difference. Now, here's a video that describes kind of an example of what this would look like. So what these wearables will do, actually take camera data, process it in real time, and give the user feedback on a display of what step they're on in the process as they're tightening down all these fasteners.
Okay, so I see the video, I see what the glasses are doing, I see the tool, but how are those two interacting?
Sure. Now, to build one of these aircraft, there are literally 1,000 different fastening tools that they may need to choose from. And as I mentioned earlier, they're already working on these smart production tools. So if we combine these two technologies, the worker will actually have a tool that will know what specific fastener that they're working on and can provide the right amount of torque for that specific fastener and log that information to a database so they can go back in later and kind of analyze it for quality purposes.
Okay, quite a lot of function into one system, so sounds perfect for our CompactRIO system, but I think carrying that around in your airplane is kind of bulky.
You're right. And you know, if this was a few months ago, that's exactly what they would have been using. But when we saw what they wanted to do, we realized it would be perfect for our new NI system on module. I have one right here. As you can see, it's much more appropriate for a wearable device. It's about the size of a traditional credit card. And the nice thing about this device is that it's built on the same architecture as CompactRIO. So it has the same flexibility and performance as that big device you would have had on your hip. The other nice thing about this is that they built their prototype with CompactRIO, but they were able to quickly port it over to the system on module because of that platform-based approach.
Very nice. So it looks also like you have some existing example there that we can show?
Yeah, absolutely. Yeah, we don't have a full aircraft, nor do we have an actual tool. But we can take recorded data from that glasses and feed it through the system on module, and we can actually look at the outputs on this screen of what would actually be sent to that smart tool. So you can see it showing what step they're on, and then also will show kind of what type of torque needs to be provided to the tool.
Wow, that really shows us how the factory of the future might look like. So how happy is Airbus with their recent progresses?
They're pretty happy. You know, their actual productivity has been really improved. They estimate that compared to some of the older techniques that they were using, their efficiency has gone up tenfold using this platform-based approach.
Wow, very nice. So again, strong statement for our platform-based approach. Thank you, Acer.
Thank you.
Thank you, Lawrence.